Assalamu alaikum. Today I am going to start a new series, SSC Physics English version, Chapter 1, Physical Quantities and Measurement. First we have to learn about what is physical quantities. Physical quantities, the things in our physical world which we can measure is called physical quantities. So the things which we can measure in the physical world is called physical quantities. Like we can measure mass, we can measure time, we can measure distance. So these are physical quantities. And another thing, measurement. The act of measuring anything, is called measurement. So activities of measuring anything is called measurement. So in science and technology, measurement and quantities, physical quantities is very important. Because in everyday life, we need to measure different things. First, what is physical quantities? Anything that is measurable is called physical quantities. Look at your book. So anything that is measurable, look. Anything that is measurable is called physical quantities. So anything that is measurable in this physical world is called physical quantities. For example, the length of the table we can measure. That's why length is a physical quantities. We can measure the mass of an apple. So mass is a physical quantities. We can measure what amount force is applied on an object. So force is a physical quantities. Now physical quantities, there are two types of physical quantities. One is fundamental quantities. Fundamental quantities. Another is derived quantity. The physical quantities which does not depend on other quantity, rather other quantities depends on them, is called fundamental quantity. In our physical world, there are some quantities which does not depend on other quantity, rather other quantities depends on them. That quantity is called fundamental quantity. In our physical world, there are 7 fundamental quantities. There are 7 fundamental quantity. There are 7 fundamental quantity. Fundamental quantities. Number one, mass. Mass is a fundamental quantity or independent quantity. Length. So length, mass, time, temperature, electric current, luminous intensity, amount of substance. There are 7 fundamental quantities. On the other hand, derived quantity, the physical quantity which depends on other quantities, like they are depend on the fundamental quantity, is called derived quantity. So force is a derived quantity because force, we know F equal to ma. Again ma, so A equal to change in velocity divided by time. Change in velocity divided by time. Again velocity equal to displacement, change in displacement divided by time. So time is square. So force depends on mass, distance and time square. That's why force is a derived quantity. So the physical quantity which depends on fundamental quantity or any other quantities is called derived quantities. Now measurement. So measurement, the act of measuring anything is called measurement. So unit, there one thing, unit of measurement. Unit of measurement. Unit of measurement. Measurement. What is the unit of measurement? The essential amount is required. The measurement standard is essential, comparing with which any measurement is done. These standard quantities are called unit of measurement. So the essential amount is necessary, comparing with whom we can measure anything is called unit of measurement. Fundamental quantities and their units. Name of the physical quantities, length. Symbol of the quantities is capital L, all or small l. We can write also small l. We can use small l also. Unit, SI unit of length is meter. Symbol of the unit is small m. Number two, mass. Mass is the fundamental quantity because quantity mass does not depend on other quantity, rather other quantities depends on them, like density equal to mass divided by volume. So volume also a derived quantity. Mass m divided by length into breadth into width or height. So density is a derived quantity. Length, mass is the fundamental quantity. Symbol capital M or small m. Unit kilogram. We use symbol for kilogram, kg. K capital letter, G small letter. Number 3, time. Time is the fundamental quantity because time does not depend on other quantity. Time, we use time symbol capital T or small t. Capital T or small t. SI unit second, short form S. Temperature, number 4, temperature. We use capital T or theta, both. Capital T or theta. SI unit is Kelvin. Short form K. And now electric current. Symbol is capital I or small I. Symbol of the quantities. So electric current we use sometimes capital I or also we use small I. SI unit is ampere, short form capital A. Symbol of the unit capital A. Then number 6, luminous intensity. What is the meaning of luminous intensity? The amount of light energy passes through a cross-sectional area of area perpendicularly per unit time is called luminosity. So luminosity is denoted by I and unit is candela, short form CD, C capital CD, candela, CD, and amount of substance, mole, substance, mole, small n, mole, MOL, mole, short form MOL only. So there are 7 fundamental quantities: length, symbol capital L, SI unit meter, symbol of unit small m, mass, symbol of quantity capital M or small m, SI unit kilogram, symbol of the unit kg, k capital letter, g small letter, time, capital T or small t, unit SI unit second, symbol of the unit is small s, temperature capital T or theta, SI unit of temperature is Kelvin, symbol of the unit capital K, electric current capital I or small I, symbol of the quantities SI unit ampere, symbol of the unit is capital A, luminous intensity symbol I, candela, CD, amount of substance mole, symbol is N, SI unit mole, MOLE, short form MOL, mole. Now multiple and submultiple. In physics and other branch of physical science, we use some multiple, like exa, symbol is capital E 10 to the power 18. So 10 to the power 18 is the factor. This one is the factor. And peta, capital P 10 to the power 15. Tera, we use terabyte for represent memory of the memory chip, size of the memory. Terabyte, tera 10 to the power 12. Giga 10 to the power 9. Mega 10 to the power capital M, capital G is the giga, mega capital M 10 to the power 6. Kilo capital K 10 to the power 3. Hector, small h 10 to the power 2. Deca 10 to the power 1. Da, symbol Da. Now submultiple, we use deci, symbol is small d 10 to the power minus 1. Centi, symbol is small c 10 to the power minus 2. Milli, small m 10 to the power minus 3. Micro, mu 10 to the power minus 6. Nano, small n 10 to the power minus 9. Pico, small p 10 to the power minus 12. Femto, small f 10 to the power minus 15. Auto, A 10 to the power minus 18.